Hey everyone! In this video, I'll show you how to launch a cloud server on Vultr in just a few minutes, and we'll use it to run a real bioinformatics workflow using Nextflow. Let's get started. Once we log into our Vultr account, we should land on the dashboard page. Here, we'll be able to see things like our current and pending charges and bandwidth usage. And if you're following along with your own account, then everything should be 0, because we haven't done anything yet. To launch a server, we click on the blue Deploy button and select Deploy New Server from the dropdown. And the first thing we need to do in order to launch a server is choose the type of server we want. And we have a few different options for that. The first is a server with dedicated CPUs, where the CPUs are fully yours. And this is best for CPU-heavy workloads. The second is a server with GPUs, which are commonly used for AI and machine learning applications. The third is a server with shared CPUs. These are often cheaper, but since you're sharing the hardware with other people or applications, the performance can vary a little bit. And the fourth and final option is a full physical server, and this is the most powerful, but also the most expensive option. Since we'll be running a CPU-heavy Nextflow pipeline, I'm going to choose a server with dedicated CPUs. Next, we need to choose a region to launch the server in. In general, it's best to pick the location close to you in order to reduce any connection or lag issues. I'm in Singapore, so I'm going to select Asia and then Singapore. Now we need to choose the server configuration. I'll select CPU optimized since I know our pipeline is CPU intensive. And once we do that, we'll see a list of available servers with the corresponding number of virtual CPUs, the amount of RAM, storage capacity, bandwidth, and also the price. So how do we go about choosing a server configuration and the resources we need? One way I do this is by writing down information about my data, the outputs I'm expecting from the pipeline, and any information I know about the underlying tools in the pipeline. So with regards to data storage, I know I have 25 gigabytes of raw sequence data. So right away, I know I'm going to need a server with at least that much space. In the bioinformatics pipeline we'll be using, I also know there's a trimming step. So in the worst case, the quality of my data is very good and I won't lose much, meaning I'll need roughly another 25 gigabytes of storage for the trimmed FASTQ files. The pipeline also produces BAM files, which contain the sequencing reads along with alignment information. So we can expect these files to be somewhat larger than the original FASTQ files. Let's estimate about 32 gigabytes for those. Finally, we'll leave some room for additional outputs such as logs, quality control reports, and count matrices, about 5 gigabytes total. So adding everything together, we can estimate that we'll need about 87 gigabytes of storage. And to give ourselves some extra room and avoid running out of disk space, let's be conservative and choose something with at least 128 gigabytes of storage. Determining the compute requirements is a bit trickier. Unlike storage, RAM requirements are driven primarily by the software being used rather than the size of the input files. For example, the star aligner, which we'll be using in this bioinformatics pipeline, can require around 30 gigabytes of RAM when aligning reads to the human reference genome. However, we're working with Saccharomyces cerevisiae, which is a much smaller genome, so the memory requirements are going to be substantially lower. So based on this, I know that 32 gigabytes of RAM is going to be more than sufficient to process our 4 RNA-Seq samples. So that's the amount of memory I'm going to choose. With regards to CPUs, I'm planning to allocate roughly 4 virtual CPU cores per sample. Since we're processing 4 samples, we'll also want a server with about 16 virtual CPUs. Now this isn't a strict requirement, but it provides enough compute resources to process multiple samples efficiently in parallel. So based on all of these requirements, I'm going to go ahead and select this server with 16 virtual CPUs, 32 gigabytes of RAM, 300 gigabytes of NVMe storage, which is a little bit more than we need, but that's okay, and 8 terabytes of bandwidth per month. And this just means that we can transfer up to 8 terabytes of data to the server per month. And this is going to cost 47 cents per hour, or $320 per month if we kept the server running continuously for that time, which we won't need to do. Now let's click Configure Software. I want my server to have the latest version of the Ubuntu operating system since that's what I'm most comfortable with. I'll set the host name and server label to my name, Kobe Chris. You can use anything you like. I'll also enable limited user login, which creates a default user with sudo privileges. Now let's click deploy. Once the server is ready, we can click into it from the dashboard. And to connect, we can open a terminal and run SSH, the username, which is Linux user, followed by the @ character, and the host name or IP address. We haven't connected to the server before, which is why we're receiving this message. We can simply type yes and then press enter. And then paste in our password. And that's it, we're connected. We've now created, launched, and connected to a cloud server on Vultr. In the next video, we'll install the tools needed to run our Nextflow pipeline. I'll see you there.